Hello, yeah, welcome to this class. My name is Dr. Kingsley. Okay, this is a continuation class, okay, on physical and chemical properties of alkenes, part 2. Okay, this class will help those who are preparing for exams such as the AP, GCSE, okay, SAT exam, NECO, WAEC, UTME. So please do well to subscribe to my videos. Thank you. So the next reaction is addition of alkanors. Addition of alkanors. So we can add alkanors to alkenes. When alkanors are added to alkenes, we get ethers. Now, when we have CH3, CH2, okay, or CH double bond CH2, and we are adding an alkanol CH3 CH2OH. Okay, what we will get is a CH3. We have a CHO, CH2, CH3. Then we have a CH3. Okay, this is what? This is a alkene. Okay, this is an alkanol. And this is what? This is a ether. Okay, now this reaction is catalyzed. It's catalyzed by conc H2SO4. So the catalyst for this reaction is conc H2SO4. Now, as a mechanism of the reaction, what actually happened is that the CH3 CH double bond CH2, okay, want to react with what? With a CH3 CH2 OH, okay, and we have what? We have an acid. The acid is H, okay, SO3H. So this is the conc H2SO4. Now this conc H2SO4 donate what? Proton. So what it actually donates is what? Is proton. So what we have here is a H plus. That is from the acid. Now this H plus from the acid comes here to what? Okay, let me write in full, the acid in full. So we have H plus, okay? You have a SO3H. I want to write it this way so that I can show you what actually happens. Now this what? This proton comes to what? To add to this place. Okay, because within these two carbon atoms, this carbon atom, okay, bearing the double bond here, have more hydrogen than the other one. So according to Markovnikov's rule, the hydrogen we add to what? To the carbon of the double bond that already have what? Higher number of hydrogen. So what we will now have is what? We'll have a CH, okay, 3. You have a CH, okay, CH, then you have a CH3. So you see that what? This carbon atom will carry a positive charge so that this thing become carbocation. This is carbocation. This is carbocation. Then what happens next? What happens next is what? Is that this, okay, this O here will be picked by this what? Carbocation. So what we have is, remember, it is a plus, okay, CH3, CH, okay, OH, OH. So this we pick what? We pick the positive carbon, because the alcohol now is now acting as a nucleophile. Okay, this one is the electrophile because it is electron deficient. So when it picks this, what we will have is what? OSO3H. Remember, this is what? Is carrying a negative charge now. So when it picks it, what we now have is CH3, okay? You have what? CH, okay? Then the O here is OS, okay? OCH2. There is CH2 here, okay? OCH2. So we have CH2, okay? The next is what? CH what? 3, okay? And remember, there is a hydrogen here, which is what? H plus. All right, then we have a CH what? 3. All right, now the proton will go off from here. So there will be elimination of what? Proton, because this oxygen that is a neutrophil will pick this what? This proton. Okay, here. When the proton is picked, what will now happen is that the H2SO4 will be restored, so that proton here plus the hydrogen here will be 2 hydrogen, which is H2SO4. Then what remains now is what? Is a CH3. Okay, we have a CH what? 2. Then CH what? 3. Then we have CH3. That is the mechanism in which this reaction takes place. Remember, proton from what? From the acid, okay, come to add here, so that carbocation is what? Formed. Then from the alkanol hydrogen add to the what? To the positive charge carbon here, okay, so that we get this compound. Then the proton leaves, so that we can finally recover our what? Our ether and what? And our acid. So in summary, we say that what? Alkenes react with what? With alkanols in order to give us what? To give us okay, ether. Now the sixth reaction that we have as a reaction of alkene, number six reaction is addition of conc H2SO4. We have addition of conc H2SO4, that is conc sulfuric acid or conc tetraoxosulfate acid. Now we have CH3, CH double bond, okay, CH2, and we are adding H2SO4. Okay, remember this H2SO4 can be written as H, okay, SO3 as HOSO3H. Okay, yes, so that is it. Now this is hydrogen. This hydrogen can go off, so that one is attached to here while the other one is attached to here. Now if you are to ask, this compound here, which is H2SO4, where will the hydrogen be added to? The hydrogen will be added to the what? To the carbon of the double bond, this one that have what? Higher amount of hydrogen. It also shows that this reaction also follows what? Markovnikov's rule. So with the hydrogen add here, YOSO3H we add to the other place. So what we have is what? We have CH3, okay, we have CH, okay, we have OSO3H. Then here, when hydrogen add to this place, we are having what? CH what? CH3. So this compound is what? Alkyl hydrogen tetraoxosulfate 6. So this is propyl hydrogen tetraoxosulfate 6. That is propyl, okay, propyl hydrogen tetraoxosulfate, okay, sulfate 6. So that is the compound. Anytime an alkene react with what? With conc H2SO4, you will get what? Alkyl hydrogen tetraoxosulfate 6. This is the sixth reaction, okay, chemical reactions of alkenes. Then we can also take the seventh reaction. Now the seventh reaction, okay, number 7, okay, is reaction or addition of two hydroxyl groups, okay, addition of two hydroxyl groups. Now what happens is what? That alkenes can react with KMnO4 solution, okay. When alkenes react with conc what? Km, not conc, yes, but when alkenes react with this oxidizing agent solution, okay, solution of KMnO4, what actually happens is what? Is that it seems as if you are adding two hydroxyl groups, okay, to the what? To the alkene, so that if we look at the reaction, you find out that when we have alkene like CH2 double bond CH what 2, we are adding what? We are adding KMnO4. Okay, remember it is a solution of KMnO4. Because it's a solution, we have what? Water, because it's a aqueous solution. Now what oxidizing agent actually donates is what? Is oxygen. So when this reacts with this, what you have is CH2OH, then CH2OH. So the compound is what? Is ethane 1,2 diol. Ethane 1,2 diol. Now what actually happened? How do you know what happens here? What actually happened here is that what? There is what? The KMnO4. The KMnO4. What it donates is what? Is oxygen, because oxidizing agents donate oxygen. Then you have here, which is what? H2O. Can you see that this thing is as if it is what? 2 hydrogen and what? 2 oxygen. So it's just like OH bonded to another OH. So that is what? I'm just telling you how to remember the reaction. Oxidizing agent donate oxygen. Then there is what? Water for solution. So is 2 hydrogen here and 2 oxygen. So which is can be rearranged as what? HO and OH, which is 2 oxygen, 2 hydrogen. So when this thing what? Cleave here, one of the OH will attach to what? To one of the what? Carbon bearing the double bond, while the other one will attach to this one. That is why we have what? This reaction. Now that is the 7th reaction of what? Of alkanes. Number 8, the 8th reaction of alkanes is addition. Number 8, addition of bromine water. Bromine water, or if you like, chlorine water. We can add bromine water or chlorine water to alkanes. Now when we have CH3 CH2, then you have CH double bond CH2. Okay, when you add this, what you have is addition of bromine water. Bromine water is actually what? Aqueous solution of bromine. Now that is a bromine plus water, bromine plus H2O. That is aqueous solution of bromine. So when you add this, what do we have? Bromine is Br2. Okay, Br2. So this is propene plus what? Bromine plus water. That is bromine water. So when we take this, what we'll have is what? Is, okay, 1 bromine, okay, is added to this place. YOH. Okay, let me show you the mechanism of the reaction so that you can understand this reaction. First of all, what happened is what? Is that what? Br2 react with what? H2O. When Br2 react with H2O, what you have is what? Is a HOBr, okay, plus what? Plus a HBr. Okay, so this reaction will be as a kind of addition, okay, of this hypohalous acid. This is what? Hypohalous acid. Hypohalous acid. So because this is a hypohalous acid produced first by the reaction between this and this to give this. So this is already a product that is formed. Then this compound now is the one that will be added to what? To the, okay, the alkane. So this is added to the alkane. Now it's just as if we have CH3, okay, then you have CH double bond CH what? 2, then plus HOBr. Remember this compound is just like HO then Br. You can now see that what? That one of these will be added to what? To one of the carbon, while this will be added to one of the carbon. But this reaction obeys what? Markovnikov's rule. Because it obeys Markovnikov's rule, the OH will be added to the what? To the carbon of this double bond that have higher number of hydrogen. So OH should be added to this because it has higher number of hydrogen. So what we'll now have is what? Is CH3, okay? CH, then Br, then you have what? CH2OH. So that will be the compound that will be formed. So in a nutshell, when this react with bromine water, what will actually be formed is what? Is CH3, okay, CH, you have Br, then CH2, okay, OH, then plus what? HBr. So that is the general equation. The general equation is when you write this propyl with bromine water, you get a compound which is what? Which is this compound and what? And hydrogen bromide. But I've given you the short method by which okay, you can go through the reaction. First of all, this and this react to give us what? Hypohalous acid, then plus bromine, which is this. Then this one that is remaining here is now the one that will combine. The hypohalous acid is one that is being added to the what? To the propane, so that you can get this compound. Now, what is the name of this compound? I want you to know that this compound is what? Is a okay, halohydrine. Okay, is a hydrine. Okay, that is a halohydrine. Okay, I can wipe the board. All right. So what is formed is what? Halohydrine. This compound is halohydrine. Why is it called halohydrine? Halo because of what? Hydrogen. Hydrine because of what? Hydroxyl group. But you might ask, is hydroxyl group called hydrine? Not in a sense like that. Hydrines are usually compounds that are related to water. Okay, and when you write alkanos, ROH, alkanos is related to what? To water, because water is HOH. Now we see alkanos, okay, as compound of water in which the hydrogen of water is replaced by an alkyl group. That is why alcohol is what? Is seen as a hydrine. So halo because of halogen, then hydrine because alkanos OH group is seen to be obtained from water. Now, thank you. Do well to subscribe to my videos, okay, like and share. Please share this video to those of your friends who might need it. Thank you.